So we didn't really go forward with this much. Then we looked at the extended aeration advantages. It can handle variations in flow and loading rates well. Systems are odor-free, lower footprint, low sludge yield, right? And the disadvantages were the startup and stabilization period is longer. Now this is a killer. Every time you have a disadvantage that doesn't work for this, that one thing would make you drop it, right? So this is the killer here. The stabilization period was too long, right? It does not handle denitrification, phosphorus removal well. You could probably have put more systems on to do that part, but if the startup takes time, then that's a deal breaker. The longer aeration periods require more energy, even that's not a deal breaker. The deal breaker is the first one. The startup and stabilization period is longer, right? And of course, it's difficult to sustain active biomass during low flow or no flow, which is again critical, which is again a deal breaker, because you cannot have a fair startup every year, right? The MBBR, this one was considered very seriously. The load fluctuations were easily handled. The toxic load fluctuations do not impact the performance of the plant. Nitrification is very effective. It's a smaller footprint. And it can be built in a modular way where you can keep adding more modules as you go, right? But the disadvantages, again, it has a relatively long startup time for the biofilm to develop, right, in the initial startup. So the developing of the biofilm is critical to the treatment process efficiency. And if that takes more than the 2 months, again, we're done. So that's a deal breaker. So this is where we had like literally a toss-up between which aeration process to go for. And it's difficult to sustain the biofilm in the absence of regular flow in continuous feed. Then we looked at the sequencing batch reactor. So the advantages, it has multiple processes handled in one chamber, so it's lesser footprint. Quick startup and stabilization. Among the aeration processes we looked at, this one had the faster startup and stabilization. And it handles sewage from upflow anaerobic processes as well. This is critical because we are actually looking at a combination of technologies here. Then there's a high degree of automation ensures higher level of control, right? The SBR processes are automated to a point where everything is centrally monitored and controlled. The disadvantage, it requires well-trained and skilled workers on level of, high levels of automation. You can't just have some Joe go in there and run the plant. You need people who understand the process, who understand the system very well. And 2 or more basins required. Now neither of these is a killer, so we could go with the SBR, right? So then the UASBR, the upflow anaerobic sludge blanket reactor. So it's highly effective for warm and high pollutant load wastewater. Now this is exactly what we have. We have high pollutant load and warm wastewater. The temperature there in this tropical forest, the lowest it goes is about 18 degrees, and the highest is about, say, 35, 36 degrees Celsius. So you actually have, water which is between 20 and 32, which is reasonably warm. And then we've already talked about the pollutant load, the BOD, COD being very high, right? So that plays into the advantages of the UASBR. So once stabilized, it's resilient to shock loading and varying parameters of incoming sewage, okay? Then the active biomass survives with no flow or very low flow as the ambient conditions are highly conducive. So this one looks very good so far. Disadvantages, the initial startup stabilization process takes time and delicate nurturing of biomass to reach stabilization. This is true, we've experienced it, but once you get there the first time around, then you don't have to do it every time. It pretty much, the biomass stays active. And it's not effective for cold and low potency wastewater, but this is not a concern for us, right? So what we looked at is the combination technologies that would work for us. We had the UASBR plus the MBBR, and in both the cases, the initial startup was longer for UASBR and MBBR. So that didn't let us go with that. Whereas in the case of UASBR plus SBR evaluation, the sequencing batch reactor could get started up the very first time around fairly quickly, right? So once it does that, and you can get the USBR stabilized on the side. You actually have both systems complementing each other and working very well. So this is what we implemented. And the first year of operation, this plant now has been running for 3 years almost. The first year of operation, the SBR operations was started and stabilized before the USBR. Okay? Because that's the one that actually gets stabilized much faster. And once the SBR was stabilized, then we started taking in water into the anaerobic chambers. I mean the wastewater. Right? So the very first time, it took 20 days for the wastewater to be treated and